Great. Well, I sort of gave you a brief introduction earlier as the founder of DDD Europe, an extensive author and speaker on domain-driven design topics. And yeah, I mean, I think that's probably all I need to say, but I want to say thank you very much for joining us tonight, or this morning, as it is in your time zone. And I will hand over to you.
All right. Well, thanks for having me, and congratulations on starting the DDD Australia meetup. Trying to share my screen. Is that working? All right. So yeah, the Miro board, I posted the link on the chat in case anybody wants to mess it up. You can use it however you like. So maybe a bit about me. I'm Mathias Verraes. I live in Belgium. I read Eric Evans' DDD book in like 2009, I think, and it was an eye opener. It was like finally I was sort of seeing how people could actually build very complex systems and still make sense of it. And then I started doing some projects with DDD. I ended up doing freelance consulting and training on DDD. First started Domain-Driven Design Europe, which is the largest DDD conference in the world. Next edition is in June, and in Amsterdam. And then I started Artling, which is a consultancy because I had too much work to do myself. We help with software design, with domain modeling, usually for, let's say, more organizations with a lot of complexity, like finance and logistics and these kind of domains. And we also look at strategy. We call it design strategy, right? You can have a great design and a great model, but if your business doesn't work, if your team organization doesn't work, if your product vision doesn't work, it's not going to have a huge impact. So it's sort of looking at everything that has an impact on design and thinking about that. That's a very short version. So about this talk, I prefer more of a conversational style. So I don't really have a lot of slides. I might not even use them. I'd rather, if possible, right, that you ask questions, that we have more of an interactive thing going on. Well, to be completely honest, I use these meetups as a way to test out how to explain things, and then the feedback is very valuable, and then I learn myself how to explain it better. So the idea that the thing I want to convince you of is sort of the value of bounded contexts and how they are not domains, or they shouldn't map to domains one-on-one. These concepts often get conflated. So I want to sort of break that idea and give you sort of a better model of thinking about bounded context. I want to help you use them as a design tool, because that's what they are. And then if there's time, I want to also tell you how focusing on meaning is, well, that's the idea, of course. It's focusing on understandability and meaning, but also that it's not enough and that's not realistic, and that you're going to have to deal with all the trade-offs that you have in software design. So let's talk about understandability first, right? Because I think it's like one of the biggest bottlenecks in software design. Maybe you've read these kind of research that pops up every now and then, that developers spend most of their time reading code. And even that is sort of a simplification, because you're not just reading, you're sort of reverse engineering. You're trying to understand what the code does and how it works and where stuff is, and trying to navigate it and figure out where exactly you can do a change, what the consequences of that change will be, what other stuff will you break while you're making that change. A lot of organizations still have a huge sort of process for getting things in production, despite 20 or 25 years of Agile, where a lot of effort actually goes to figuring out if we didn't break stuff and if it's going to work. There's also all the time that is spent before making changes, which often, is sometimes it's months of people figuring out whether it's even feasible and what all the stuff is that would need to be changed in order to introduce a new feature or change how something works. So the real cost there is that we don't really understand our systems very well, um, which is of course a natural consequence of how we build them and how they evolve and how we keep adding stuff to them. And in general, in my experience, we don't really understand the domain very well that we're building systems for. In the end, what ends up in the code is not what the customer wants or what the product owner wants or what the analyst described, but it's what the engineers understood of the problem and of the domain. And so there's always a lot of knowledge getting lost that way. And we simply don't understand our systems well enough to be really productive. In fact, that's how I would define understandability in this context, right? It's do we understand enough about the system and the domain to be productive in it? So I think that as an industry, we haven't focused enough on how to keep our systems understandable. And that's just a lens of what, you can use this lens of understandability to look at what domain-driven design is actually for, right? It's by definition, it's for tackling complexity. It's tightly coupled to this idea of meaning, right? Of understandability. So we have to think of that as a cost, right? Not understanding our systems, not understanding our domain will have a cost because we will write stuff that is already not very well understood or not very well connected to the source domain. So this is like a core idea in DDD, right? We try to model this domain and we try to build a solution that looks like that model, like a shared collaborative model, a collaborative understanding of the domain. So it's not just sort of a very technical developer interpretation of it, but it's something where even the domain experts who don't know how to write code, they could look at artifacts, code, documentation, tests, etc., and still understand what it's about. You share this this understanding. So whenever we're adding stuff, we're actually adding meaning. We're adding new concepts, and these concepts have meaning. The meaning of these concepts keeps evolving. It becomes very ambiguous. You have the same word being used in different places with sometimes very subtle but important differences in meaning. A simple example is something like order, right? It starts with, oh, we have orders. But then if you start paying attention to the language and the nuance and how people actually use this language, you'll notice that in the sales department, they think about orders slightly different than in the shipping department. If you start focusing on that, like what is different about it? Well, for starters, it's different people using these orders for different reasons at different times, right? The salespeople, they use it to build basically a contract with the customer of this is stuff we're going to send to you at this price. Whereas in shipping, it's here's a list of stuff that we need to package and deliver at some place. And the sort of needs they have are slightly different. Of course, they look very similar. And one of the mistakes we have made there in software development is that we focused on this artifact itself too much, on this order itself, right? We think of our system as or as our problem as we have to store orders and then we add behaviors on top of that document, right? We mimic how this used to work in the paper world where there's this paper that gets transmitted, but we made the paper itself, the document itself, the most important thing. Whereas in the end, it was just supposed to be support for this business process, right? So a lot of meaning already gets lost there if we over focus on artifacts. In fact, I want to go back to what Chris said about, he showed this event storm model that was events happening over time, and said, well, some people say this isn't the domain model because it has no entities. I agree with Chris here very much. It's also a domain model. We have been historically focused on what I call structural models, right, where the structure of the problem is well described and understood. We make database schemas, we make data structures, we make entities. We look at all the things, we connect all these things, so we find relationships. That's like the second layer, and then the third layer is maybe, you know, what behaviors do we attach to this. There's nothing wrong with that approach, but it's a very one-sided view of the problem. With techniques like event storming, event sourcing, domain storytelling, these are modeling techniques that focus on behavior over time first, as opposed to entities first. So we call these temporal modeling, and this is like one of the things I've been ranting about for the past 10 years, that we should focus a lot more on that, and like find models that show us how things evolve, how things behave, how they happen over time, how a process, a business process, maybe spawns different processes or influences the outcome of another process. We should focus on the constraints, on the rules that influence the process and how stuff happens over time. That's temporal modeling, and you need both, right? There's a you need both ways of looking at problems. Is that making sense so far? Of course, I can't really see your faces. I just see sort of a blur, but don't hesitate to interrupt me or ask questions, right? So going back to understandability, how do we deal with it? Well, there's documentation, of course. Good naming strategies help. You know, having good tests where the tests themselves can serve as good documentation for explaining how it works. But of course, in domain-driven design, one of the main ideas is modeling. You're always modeling, right? When, like right now, I'm trying to explain how I think about understandability and bounded context and models and DDD. I have a mental model in my head, and you may have a mental model already, and maybe now with me explaining, you're trying to form or evolve your existing model, right? So you're always modeling anyway. Models are how we see the world. We never see the world as it is. We see it as a bunch of abstractions, and we interpret the world through these models. They're always incomplete and incorrect, and they will always have wrong abstractions, but we try to get them to a point where they are useful. DDD is saying, well, let's make that explicit. Instead of all these random people involved in software development, from the domain experts and the analysts and the customers and the users to the engineers and the testers, let's actually collaborate on doing this modeling, and let's do it explicitly, and let's agree on stuff, and let's find notation styles that can help us. So when Chris was showing all these sort of methods and concepts like event sourcing and hexagonal architecture, all these things are part of DDD, but or can be used to do DDD, but DDD is more like a discipline than a method, right? It's a set of principles. If you are disciplined about applying these principles, you'll get more of the benefits. And then the methods themselves have always been evolving. So event storming didn't exist when Eric Evans wrote his book. He didn't even mention events in the book, even though he was sort of aware of it, but he didn't see sort of the importance of the pattern back then in 2003. But so we're always modeling. We do this in DDD. We do this a lot more explicit. We can make domain models. We can do system models. I think we're also in general not going far enough with these models. I think we're doing that way too superficially. Here's an example, right? You've probably seen or maybe made architectural diagrams, and they're usually like these very neat squares or rectangles with some straight lines, or all neatly structured and connected. They're very nice pictures. They have like often nice colors. Everything is sort of aligned neatly, but that doesn't look like the system at all, right? I haven't seen architectures that actually look like the picture that people draw of them. Of course, these pictures are abstractions, but they are often so simplified and nice and sort of wishful thinking diagrams that they have no use anymore. They don't really help us to understand where the real pain points are. So usually, like, these diagrams are often lies, right? They're like what we tell ourselves that we would want our architecture to look like, as opposed to how it really is. So reality is always messier than the models we draw of them. The solution is to draw more models and more ways of looking at it, and zooming in at different levels and using a huge variation of modeling styles and techniques and visualizations to do that. But so how I think about in the context of what I'm trying to convince you of here, right? Understandability of systems. The way to think about models is actually the same way you can think about it as they do in science, right? I have if I drop my mouse, I know it's going to fall down because I have a model of gravity. I don't know what happened at the quantum level. My model of physics, of quantum physics, isn't good enough to explain what happens when I drop an object. But my model is good enough for my context, which is just in general just be living in the world and not falling on my face too much. So I have a model that is useful to predict certain things that will happen in my environment. So it's a good enough model for that. In software, it's the same thing, right? If I have a good model of my domain, that means the domain is really messier and more complex than my model. But my model may be good enough to predict how things happen. What will happen if somebody does this in my business? If somebody returns something that they ordered, or if a trade is made in a financial trading system, or if somebody tries to apply for a loan to buy a house. If I have a good enough model of that, I can sort of predict what will happen there. Same for my software system. If I have a good model of my system, good understanding, it means I can predict what will happen in specific situations. Basically, for these inputs, I can expect these outputs, right? Software should be predictable like that. In reality, we don't have good enough models. That's what I was saying earlier, that we have to do all this sort of reverse engineering and testing, etc., to have to make sense of what will happen in specific situations. Ideally, a customer or domain expert or a user should be able to come to you and say, well, I had this case where the customer paid twice. What happens in this situation? Well, we don't know, right? We don't know how the system behaves in that situation because we don't have a good enough model of it. So in the same sense as in science, models should give us predictability about the behavior of our domains and our systems. And ideally, of course, those match. There's a second level there for software, which is we're always changing software, right? It's supposed to be soft. It's supposed to be easy to change. Unlike most other things in the world, like, I don't know, bridges or whatever, we build a bridge and then we expect not to touch it for the next 20 or 50 years, I don't know. And then when we do actually need to fix the bridge, we take it out of production, right? We reroute traffic, we fix the bridge for half a year, and then we move traffic back, which is not how we do software at all. We keep it running 24/7, and we're like changing it daily. So this second level is our models should give us enough predictability that we can even understand the impact of a change, right? That's like a higher level of predictability that a good model should give us. So part of that is language, of course, and if you have, had any, if you studied DDD at all, then of course you're aware of this concept of ubiquitous language. I think there we are also a bit too superficial often, that we have this model that ubiquitous language is just domain language. But that's not true. Domain language, in my opinion, domain language is a natural language, right? It's messy, it's organic, it's ambiguous, it's social. So social groups like a team or a group of users or domain experts or whatever, they develop organically a sort of language to talk about their domain, right? It's very opportunistic, right? They built this language to solve problems, right? To talk about the problems they have. There's no sort of deliberate language building happening there. In most domains. In mature domains, it's different. Like in accounting, at least over here, the domain language of accounting is, there's a set of legal terms there. There's a legal term, invoice, for example, that has a very specific meaning that is well defined. So in these kind of mature domains, language is very formal. But in most other situations, it's not, right? It's people sort of come up with new language and it sort of means the same thing or sort of means something else, or they reuse existing terms for slightly different meanings, or different social groups have sort of different interpretations of these things. It's very messy. It serves them in their social context. And even then, it's not even good enough always, right? There is often confusion and people say it's bad communication. What they mean is often we don't have a very good shared language to discuss this. So you have these sort of meetings where people are not talking about the same thing and not getting good results. But so this is a very messy, organic, dynamic language. It's always evolving as well. And that's not very practical for us designing systems that depend on having accurate meaning and that want to be understandable. So this is why this concept of ubiquitous language is a designed language, right? We are deliberately creating language where we have, we can have some sort of process. It's a more formal language. How formal depends on your context again, right? If you're like a startup in a very novel domain and trying to figure out your market fit and all that, trying to learn about your users, that language will be, fast moving and not very formal. If you're in a very mature domain, if you're dealing with, for example, life critical systems. I've worked on a drug pump. So it's just pumps for administering chemotherapy to patients. They don't sort of, when they deal with their language, it's RFCs, right? It's a process. It's a very strict definitions that are agreed upon through this process. But the level of formality depends on your context, but it's still a more formal language than this spoken or written natural language that people in the domain are using. Their job is not to design a language, right? Their job is to be productive in their domain, and they don't think about it as let's build this language. But for us as system designers, it's a lot more important. Of course, computers themselves are also like that, right? Right now we still have very strict, unforgiving programming languages that want us to be precise, and our compilers still break if we have like a comma in the wrong place or stuff like that. So just the fact that we have to encode it in programs requires us to be very formal. But that's what this ubiquitous language is, right? It's a tool for designers, right? For designers in the broadest sense of the word, but mostly engineers and people affecting the design in some way, like analysts or testers or these kind of roles. Ubiquitous language is a tool for agreeing on meaning, on managing meaning. And the better we do that, the more control we get over the understandability of our systems. That's what design is, right? You're trying to get control over a situation that is maybe not very well controlled before, right? Design is always trying to impact the change in the world. You always have like an incomplete knowledge about the problem you're trying to solve. Because if your knowledge was complete, the problem was already solved to begin with anyway, for non-trivial problems, right? And we're always dealing with sort of these trade-offs of, stuff is moving, some things are more costly, there are always constraints, there are physical constraints because software systems still need to run on physical hardware. All of this stuff enters into design process. So how do we get control over all this mess? Well, first is knowing exactly what we're talking about. That's very useful. So and the same way is, so if domain language is this language of the domain, and ubiquitous language is how we get control over the language. We have the same thing with these models, right? The domain itself is really messier than we would want it to be. When we ask somebody, how does this process works? If you keep asking questions, it's always, yeah, but then sometimes it's like this, and we had this one situation where it's like that. And there's this joke on how to interview a domain expert. They say, well, and then this happens, and then you say, well, is it always like that? And they say, yes. And you say, always? Yes. Always? Yes. Always? Yes. Always? Well, actually, sometimes. So it's always very messy. And the same way that ubiquitous language is how we get control over meaning, models is how we get control, how we make something that is an abstraction, a subset of things in the domain. It's a subset of the things that we find the most important or the most valuable or the most productive. And we try to capture this in these models and express these models in executable software and run that. And then, as Chris already mentioned, right, even that is not enough because it becomes very, very, it becomes messy still. It's hard to agree on a single model with a large group of people, and I'm talking, huge organizations that have been building software for 30, 40 years with hundreds or thousands of people. It's very hard to agree on a single unified model, partly because the needs are so different, right? The organizations still do this but used to do this a lot more, I think, at least in my experience, but maybe I'm biased because of the kind of organizations that hire us. But they try to build these huge, like, universal models for the entire organization under the belief that it's a static thing and that you can unify all this. But then they impose this, like it would be, I don't know, a few architects hiding in the basement for 6 months and then coming out with, and now here's the model that everybody has to follow. It just didn't work because it was always bloated. It was always, focusing on the wrong things, not the things that people actually need, who know a lot more about the problem than these people trying to collect everything. So the way to manage this, understandability of the system, is to have smaller bits that we can actually keep in our heads, right? That would be the ideal size of a thing, is where a single person can understand the whole thing, right? So that's where this idea of bounded context comes from, right? I think it's I think the very idea that there's the third layer of boundaries that was very new in Eric Evans' domain-driven design book. I haven't found this idea anywhere else. So we have, of course, like technical separation, right? That has, since David Parnas in the 70s, the paper on modularity, and probably before, people were thinking about how to separate systems technically. The tools for doing so have evolved massively, where now we have, we can have distributed systems and microservices and serverless. All these things allow us to have very good technical separation. Of course, there's a bunch of evolutions as well, like bandwidth became a lot cheaper, and storage and all this stuff, CPU. So we can do technical separation a lot better. Domain separation has also been there for a long time, right? We have split systems based on the domain, based on the departments, and there's nothing wrong with that. But it's sort of trivial to prove that it cannot work always, that is naive. For example, let's keep this example of a logistics company. They have maybe sales and orders and shipping and warehouse management, these kind of things. And now they acquire a competitor. So now for all these domains, they will have two different systems, right? So our ideal of having a separation where everything is neatly mapped to a single subdomain is already not working. We have for every subdomain, we have two systems. And on top of that, it's not just that we have two sets of implementations for these same problems, right? It's not that we now have two implementations for warehouse management, but we have two sets of meanings, right? Because the terminology in both these warehouse systems is going to be slightly different. Right? It's not just going to be one word has the same meaning in both ordering systems and both shipping systems. It's going to have different meanings, sometimes very subtle, sometimes not so subtle. So it becomes very messy quite early on. Actually, I can show a drawing that we did for that. Let me just share my screen again. So I hope you can see this. So if we the blue lines being a bounded context boundary, is it showing? Yes. The red line is a domain boundary, and this is system boundary. In a perfect world, this is what our systems would look like, right? Every system would manage one subdomain, and all the meaning, all the models for that subdomain are also neatly contained in this one system. For some definition of system, right? Component or module or service or deployable unit. But if we look at the patterns, a monolith is basically saying all our domains are in one big system, and all the meanings connect, right? So it says that even though these are separate domains, in theory, in practice, the concepts are really overlapping between all these things, right? I have a term here, which this thing needs to understand what this thing means in order to be productive. So this is what this message, right? Coupling at the level of meaning. That is, I cannot make changes here without having to understand how this works. That's why changes are so expensive, because I always need to sort of understand the whole system in order to do things. So it's very expensive. And then people say, oh, let's do microservices. So we have all these small system boundaries, but the domains, well, they could be like, well, this picture is maybe also more messed up than it's drawn here. But so these domains are here, and a single microservice might actually deal with different domains. So when I'm trying to do anything, I still like the idea of microservice. Part of the idea of microservice is what if we have a very small system, it's going to be a lot more easy to understand and to evolve or even get rid of. But in practice, if this thing has depends on meanings for all these different domains, it's going to be messy anyway. It's still going to be deeply coupled. It's just that the coupling is now not visible in the code, but it's existing in the connections between the things. Right. So the complexity has moved from inside the code to outside the code, but it's still there. You didn't get rid of it. Modular monolith would be a better design, of course, where there's for every domain you have a component. It's still one big thing, but meaning is nicely aligned with these subdomains. Here's the wrong. These are just a few patterns, right? It's not intended to be a complete representation of all patterns of how these things overlap. But here we have sometimes we could have some microservices that are logically grouped in a single bounded context. So that means that these four microservices would have the same definition of a term, of a concept, even if they don't necessarily use all of it. But here when I talk about order and here when I talk about order, it would mean the exact same thing. Whereas here I may talk about order, but it means something different, right? So that's sort of what bounded contexts do, right? They say within this boundary, all these meanings are going to be consistent. The rules are going to be consistent. There's not going to be ambiguity. We draw a line around that, and then we guarantee it inside this boundary, but we don't guarantee it outside this boundary. So if here we define a term, we're not saying everything else has the same definition. This is how you talk as well, right? When you use bounded context, you say, well, the order in the sales context, and we do, blah, blah, blah with this thing, or the order in the shipping context. And the people in this conversation should know that these terms have a different meaning, right? It's like you're literally context switching. Context, the word context literally means that the meaning of terms depends on the meanings of the surrounding terms, right? So here, the meaning of order depends on the concept of selling something, of agreeing with the customer on something. All these terms are closely connected. And in shipping, let's maybe label this so it's a bit more. So if this is sales and this is shipping, here, for example, we don't really care about what we agreed. We don't really care about the price. All we care about is here's this list of goods that need to be delivered to this place at this time. That's the model for order. It has a different understanding. Same for if we do, well, this is shipping, but actually shipping doesn't even care about what the goods are, but maybe warehouse management cares about, it's these goods need to be packaged together. Here we care about, okay, this is the package that needs to be delivered. So order has a slightly different meaning. Product has a different meaning. Here, product is something you can sell. Here, product is something that you have in shelves, right? You care more about the bulk. I have 1,000 of this product on the shelf in some specific location. Location matters here. Here, location doesn't matter as much or doesn't matter at all. So it's these subtle differences in meaning, and we make that very explicit. We draw a boundary around it, and then we try to protect that boundary, and we try to think about everything. What sort of meaning, where does this belong? Where do we move this concept? Can we make sure it's nicely separated? So the counterexample is, like traditionally people would build an order object and attach all this stuff to it, right? It would have information that is only needed for shipping and information that is only needed during the sales process, etc. So this is where this temporal modeling comes back in, right? You can start thinking about what are the processes that we really care about, as opposed to what are the artifacts. And instead of saying let's model order and attach all these properties to it, and then attach relationships and behaviors to it, we could say what if we model the selling process, right? What if we model the shipping process? So I'm actually even in favor of not calling it sales, but calling it selling, right? A naive way would be like having an order context, which is named after, if you have an order context, you're basically naming this after the entity you're managing, but it doesn't give you any guidance of what sort of problems it's supposed to solve, what sort of meanings belong with order. So it becomes very arbitrary. It's just because these three domains happen to use the same term order that we attach all this stuff to this single concept. Whereas here we're selling, what do we need? We're saying, what do we need to sell stuff? Well, here's like the minimal model that we need to sell stuff. Here are the behaviors. Here's the process. What is part of this process? And at what point can we hand over control of this process to warehouse management or to shipping or whatever? And what's the minimal information that we need to transfer from this process to that process? Right. So I hope this makes sense. I hope I'm showing here how our boundary becomes a lot smaller and more focused, right? If here we said, let's attach everything that has anything to do with orders onto this thing, it becomes big. It becomes this God class or this huge, deeply interconnected thing. But here, if we say, let's deal with all the concepts that we need during selling, and then we make an abstraction of that, which is the minimal stuff that we need to do shipping, and that's the only information that we send in a message to the next business process, and then they do their thing with their concepts and their terminology and their meaning. And now these two things are a lot easier to understand because you're not like being dragged down by all the noise of these other domains being mixed in there. Is that making sense? So let's see where to go from here.
Just while you're having a break there, Mathias,
Sure.
I'll just note we do have a roaming microphone, so if anyone has a question, just call out and we can bring it around. If anyone, you don't mind some interruptions, I guess?
No, I do not.
Hello.
Is there a question? Because I can't really see the video very well.
Yep, we've got a question. I'm interested in ownership. One of the problems for organization is ownership. Can I run a line around like the boundary context and say that's the boundary of ownership? Does that make sense at all?
I couldn't hear you very well, but I think you're asking about ownership and the relation between ownership.
Yeah, I think so. I think maybe we're having an AV issue where the microphone is coming out of our speakers, but not necessarily going into the Google Meet. But yeah, just to repeat it, it was about ownership, and it was about if you draw a boundary around these concepts, can you also make that a boundary around ownership?
Yes, that's the ideal, of course, right? Where it's not on this picture, but where ownership, as in the sense of what group of people, what team knows these concepts, then if that's neatly aligned, things become a lot easier as well, because the only thing now these two teams need to coordinate on is this message about when we've finished the selling process, what information do you need? We don't need to understand each other's models anymore. We don't need to coordinate on that. So ideally, a single team would always have their set of bounded contexts that they own, that they can decide what the terms are, and they decide on the ubiquitous language for it. So you reduce coordination. Coordination is always expensive, right? That's the whole that's central to this whole problem. There's actually research that ThoughtWorks did that if information leaves the team, it takes an order of magnitude longer for work to be finished. So every time that you need to coordinate with another group of people, it just, by the time you have set up the meeting, etc., and it all takes much longer. So if we can minimize coordination, if we can have better ownership with better boundaries, we will be a lot more productive. But we must not underestimate that if you try to be too autonomous, then there's no coordination happening, and that means that it doesn't. Nobody will know where to put stuff. If coordination is not happening at all, then selling will be confronted with some kind of problem, and they will add stuff to their boundary that actually would better be solved by another team or context. So that's the whole tricky thing, right? How do you have just enough coordination to make sure that stuff ends up in the right place? So there's it's like waves in the industry, right? There's sort of you have this wave where everybody wants more alignment, and we're talking about how to align stuff better and how to coordinate, etc. And then there's the counter wave happening, which is, we have too many meetings and too much coordination stuff. Let's find ways to be more autonomous, and then that gets all the attention. And then when that goes wrong, people start talking about alignment again. So the reality is that it's always going to be a trade-off. But then people are sort of naive and like, well, this advice that people give about, make your teams autonomous, give them ownership. I feel like often they're sort of too naive about, is the system ready for that, right? Perhaps you've heard of Conway's law, which dates from the 60s, which says that the system design will mimic the organization structure or the communication structures within the organizations that design the system. So people think that if we simply change the organization structure, that we will now have better design. But it's not that simple. It only works if your design is very flexible, which most software systems that I've seen are not very flexible. They're very expensive to change and to restructure. So just thinking that, let's split into, let's Spotify or team topologize, or use these organizational models, and then our system will be fine. No, your system, it works when you have a green field and you organize you set up your organization in the way that you want your system design to be. But if you already have a system design, it's very hard to change, and simply changing the organization structure is not going to fix the design structure. Does this help with your question about ownership, or was there something specific that you had in mind?
I was thinking about when you've got a model that's evolved over time and become quite complicated, then can you do that ownership on something that's a bit more torn? And
So the follow-up there was, if you're working in a system that's evolved over time and is starting to get a bit messy and convoluted, can this kind of boundary help you tease it apart? But I think you kind of already answered the question with your last comment there.
Yeah, it's well. Sorry, was there another follow-up thing? Or?
No, it's just the microphone being moved.
Okay.
Are there any other questions?
You're going to have to deal with change, and I think part of it is that we don't have the habit of doing that. We wait until things become problematic, and the reason is that it's always cheaper to add something to an existing thing than to first split up the thing and then add the new thing in the right place. Carlo Pescio wrote about the physics of software, and he calls this effect gravity. Right? It's always your second line of code is going to be very close to your first line of code, and your second concept is going to be in close to your existing thing. And it's always, the more mass it has, the more it attracts more mass. So you add the next thing into your existing system and structure and design, as opposed to rethinking your structure first. It's always going to be cheaper, and at the same time, every time you add more mass, it becomes more expensive to escape that gravity, to split it again. So the only solution is to do that sort of work continuous, which is in DDD, right? It's called refactoring towards deeper insight. Subtle. No, not subtle. I lost the supple designs. Where you're always doing these small refactors and this small renaming and this, like, let's split this off. Maybe it's a bit premature, but if it looks premature, but it isn't premature if we know that we're going to have to build a lot more stuff on top of this, right? Then splitting something where it doesn't feel like, is this even big enough to split? It's worth doing because it has a long-term payoff. So it's this sort of continuous modeling, this continuous rethinking that will get you in this place where you have good boundaries. This picture is supposed to represent that this interaction between systems and bounded contexts and domains in a realistic, large, complex system that has been doing DDD for a while. You'll see a bunch of these patterns. In fact, there would still be some part where maybe there is a bit of a, oh no, that's wrong. But there is some big ball of mud still part of this system, because here we decided that it wasn't valuable to try to fix this. Why not? Because it's stable enough. It's become a commodity in the market. We're not doing investments here. We're not expecting this to evolve. So it's fine to leave some of this stuff in an ill-understood mess for now, if that's not where our focus is. There was another question. Is selling akin to business capability? Yeah, in the chat. Business capabilities are a good heuristics for looking at how should we separate these things. What I want to do, but I'm sort of running out of time, is mention a few of these heuristics. But first, Chris, I think you said there was another question as well.
Yeah, there was in the audience here. There was one. Yeah.
Yeah, there was, but yeah, you actually answered it already, so I'm all good.
Oh, turns out you're prescient, Mathias. You already answered it. So
okay.
Prescient. But I think there was a question on the chat about business capabilities. I think I saw it pop up. I don't know if you already kind of feel like you addressed that, but
it's a heuristic, right? So the way to look at this is how are we going to find these boundaries, right? And which are valuable and which should we focus on? That whole like strategic thinking about our design. Business capabilities are one way. Processes is another, right? How are these processes happening? In fact, I have a drawing here which I don't have time to explain, but there's these archetypes for processes. One is we're constructing something, we're building something, we're negotiating something, we're building a plan, we're building a contract, a specification, a thing. Like, the sales order happens here, right? We're building this order, and then we sign off on it. We say, now this thing we constructed is final. It produces some artifact, which could be the order document, or it could be the contract itself, or something that prescribes now the productive part. In this process, we are doing something productive. We have maybe it's an insurance policy that we signed, and then a claim comes in, and now we have a process of actually fulfilling that claim based on what was decided in the contract. So the contract prescribes the process, and then on top of that, while these processes happen, this execution, this operational stuff, we are monitoring that. We are doing analysis, which feeds back into learning, right, into new understanding about how this business works, or what is valuable, or what is, most effective, which feeds back into how we do things in future processes. So this is just one way of looking at business processes, but it's a very powerful one to help us think about where to split stuff, right? If we this is saying split off, instead of considering my insurance thing as one big bounded context, can we use this heuristic to say, well, separate the contracts, building and negotiation, and then all this stuff here is detail that we don't need once we get a claim. All we need is the minimal information that is in this artifact. Right? So it allows us to. It's a heuristic for finding opportunities for splitting systems. But here's the hard part about software design, right? There's always these many trade-offs and these many heuristics that you can use to find how to split up things. So a very interesting and valuable way of splitting bounded context is also to look at change. So we can look at our domain and say, well, here is maybe this is, we think of this as one domain, but here's some aspect of it that has high volatility. For example, we have, let's say in online gambling, for example, I know that there's a lot of volatility in the rules about it, in the laws and in the regulation about it, because it's one of those areas where governments like to show, how virtuous they are, and it's one of those easy things where it doesn't have a huge impact on the economy if you change the rules a lot, and it can give you, you can use it to sort of show that you care about these moral issues, right? So it's sort of this, like this poster child of a moral government kind of thing. So regulation and changes, markets or countries have their own regulation. So if you're building this online gambling thing, it would actually be very valuable to split off the things that are maybe quite stable. For example, you have your own process of, how you get the money and how the wallets work, and I don't know, that sort of stuff would be quite stable, as opposed to the regulation on that. What are people allowed to do? What are you allowed to do? So if you can separate that into two bounded contexts, the frequency of change in one context is high and in the other is low. So you get the stable part is sort of isolated. You don't have to worry about, you don't have to change the stable part because the volatile part changes, right? So you have a better separation of understandability and meaning, etc. And you can, another way of thinking about it is that you can focus expertise in the bounded context that needs it, and other expertise in another, without these having to coordinate too much. So it's the frequencies of change. You can also look at the source of change, right? Who's authorized to change the rules about this subdomain? If these are different actors, different roles, like here, maybe it's the warehouse manager decides how to organize the warehouse, and or the maybe you're a factory, and there's your machines are not going to be replaced every week, but maybe the sort of things you assemble with the machines changes regularly. So is there a way you can separate on the frequency of this change, or the authority of who changes that? So it's not pure about meaning here that we're separating, but it's about the change in meaning that we're separating. Another way of looking at that is political in the organization, right? Who has the money? Who has the sponsorship? Where is the organization heading? Who has more authority to do things, or who has ownership to do things. If you can separate your bounded context on that, it's going to be easier, right? So these are just a few examples, right? Another one is the cost of errors, right? I would want to look at my especially in sort of critical stuff, right, where errors are extremely expensive. Can I split my bounded context based on here is stuff where errors are cheap or easy to fix, right? Something goes wrong with the order, I can make a phone call and it gets settled, as opposed to here, mistakes are very expensive, like somebody dies if there's a bug. So if you separate that, you can focus the effort on the one where the cost of errors is high without dragging along all this other stuff, right? So you get these very focused, they're not just subdomains, right? They're focused on other aspects of subdomains that, or you could even group them across. So you could say here are 3 subdomains, which each have some area of them that has a high cost of errors. Let's move all 3 of those areas in one bounded context. So this bounded context is dealing with 3 areas of 3 different subdomains. But the reason it's together is because the philosophy, the way of thinking about it, the effort we invest in it is similar. So there's all these sort of heuristics that you can use to look at the separation, and based on that, make trade-offs and end up with a better design that's more manageable, that is more productive, that is easier to understand. Yeah, and I know there's like a lot more to say about this, but I hope this gives you some hints at least to think about this. Are there more questions about this?
Yeah, there's a question on the chat.
To what extent can the complexity of interfaces or events imply that we've got our boundaries wrong? Yeah, for starters, you look at the language, right? An event. The nice thing about an event, you describe an event, and it has all the terminology it needs. If you pick the name right? If the event says, the name of the event says what the thing is doing, what is happening at that point in time, right? There's an event should always be granular, that there's a before and after, and you could say before the situation was like this, after this event has happened, the situation is like this. So the name and the properties, and that already gives you a good hint of why are there 2 terms in this event that come from a separate domain, or that have maybe, that deal with separate meanings. That could be a smell that you're coupling things. Maybe there's a way to separate that. You can go a step further, which is also when you do event storming, also model the constraints, like put the business rules on that picture and give them very clear names of what the rule exactly is doing. So you say, well, now I need to come up with an example, but let's say we can only finalize the order if the customer is in good standing. That's a rule, right? You could have maybe a better way of describing that rule, like a more technical way to describe it would be if the balance of the customer is greater than or equal than 0, then we can send this order. So now this language of this business rule describes the connection between two areas, right? Because it has, being in good standing is in the accounting part of the system. Sending the order is in the shipping department. This rule represents a connection between these 2 things. So it's a sign that there is some, cross-boundary stuff happening here. And then you can think about how to organize or separate. Let me actually draw that really quickly. So if this is order was sent, there might be a command. So somebody saying send this order. And now I'm saying there's a rule in between that says, let me give that some color, zoom in a bit. So balance must be greater or equal than 0. So this picture is now saying if somebody tries to send the order, the system will check the balance and either send the order or do, I don't know, something else or not do anything or whatever. So now you can connect this back and say, where does the information come from? Well, because something here in some other place has basically invoice was sent and invoice was paid events. So this constraint needs to know about these two events. In fact, I would even do that a little bit more explicit and connect them both. So now we see that this rule can only be decided if these events have happened and we know about the outcomes of this, right? So this is like a fundamental dependency that this rule has in order to continue the process. So on the face of it, it's very hard now to separate this because the orders depend, or the shipping depends on knowledge from accounting. But if you start really thinking about what does it need to know, maybe you can separate this and you can say, actually, do we need this level of detail here? Well, maybe we can move this somewhere and just say, which, well, you could even generalize it more like blocked or unblocked. And we could say there's something that manages whether a customer's orders are blocked or unblocked. And the rule here is simply the customer must be unblocked. Of course, we're introducing a concept here, but now the dependency is much is spread out, but is separated basically. So this depends on that. But we can draw a boundary here and say the amount of knowledge that orders needs to have about invoices is much smaller. It doesn't actually need to know about the existence of invoice. It's just that both these systems need to know about the concept of blocking, right? Did we make it more complex or did we make it simpler? That really depends on context. We might have, dozens of these rules. Maybe there's other stuff like, if they have open customer support requests, and maybe there's a bunch of things. So instead of order depending on 3 different subdomains, it only depends on this small abstraction. And these things can evolve independently without having to touch orders. We don't have to understand anything about this to change any of this. They don't need to understand about each other. They just need to understand this one shared concept. So basically, by separating, we've managed meaning. We've managed the understandability of our system, and we found an abstraction that helps us do that, right? So I hope this helps with your question about interfaces, but basically the interface now is much smaller, right? That's what I'm trying to say, as opposed to depending on all these interfaces. I see there's more questions. I don't know how much time we are allowed to spend.
Well, we do have a deadline to get out of the room, but a bit shortly after 8:30. But I mean, this is great. I'm very happy to keep going, Mathias, if you're happy to keep answering questions. We were thinking about having some internal discussion here, but I'm sure we can find some time for that. But was there another question in the audience? Yeah.
Like, we talked about getting it wrong, and it would seem that it's a high impact change to shift those boundaries. I'm just interested in what are the ramifications of shifting the boundaries to the way you think will happen, the whole operating model, I guess.
Did you catch that?
I think so. So when you get it wrong, what are the implications of shifting the boundaries?
Given that by its nature, it's a high impact type change.
So given that by its nature, it's high impact to shift boundaries.
Yeah. Yeah, and the thing is, we wait too long until we accept that it's wrong and that we need to shift the boundaries, right? So the first answer is always like, and I see a question on the chat as well. Does flexible system architecture exist, or is flexibility achieved by micro changes over time? You answered your own question, right? It's all these micro changes that seem very useless at the time you make them, but they add up. There's this sort of graduality. There's this accrual of better structure and meaning. If everything is granular and has a precise meaning and is well understood, these things become a lot more composable, right? If you cannot predict where you will need flexibility, but whenever you need something to be more flexible and you build in that flexibility and you make that change, then over time your system will become flexible in the parts where it needs to be flexible. It's like it's sort of empirical, right? It's not I predict I need flexibility here or something. You just make the thing as you understand it at the time. But then if you need to change it, you actually change it, and gradually the architecture's DNA will become flexible in the places it needs to be flexible. So what you end up like a mature DDD system, and they exist. They have this property where you end up not having to change existing things themselves anymore. Every concept has like like there's a value object for everything. The value object has its own behavior as well, computations. They are composable. You can combine them into structures. Business rules become first-class objects, right? Instead of being if statements that are in the middle of a large, block of code, you have separate business rule objects that represent some behavior, and you can combine them, you can compose them, you can make a strategy object, which is really just a sequence or a structure of a number of business rules. So this property that you get is that changes to the system become, instead of changes to code, they become changes to, you add more things of the same type that you already have. So you have a type of business rule for something, and then you add more variations. Maybe whenever a new client is onboarded, they have their own rules, but they already fit in the types of rules that you already have. So all you have to do is add these new types, or you restructure, or you reorganize them, or you maybe you have a business rule, but then a different client comes with a different business rule, but it's a variation of the first one. So you can actually adapt this one to be configurable. So now you have configurable business rules in your architecture. And now whenever maybe after a while, you've sort of seen all the cases, a new customer onboards, and it's really just a novel recombination of these business rules in a new thing. So over time, you rarely have to modify code, but you modify these higher level abstractions or how they are combined, or how you change the order of a business process, you change the order of the steps, as opposed to having to change a lot of code. You just reorganize them. There's a place where you see all these steps in the order that they're supposed to happen. So you get this sort of flexibility, and even if you need to write new code, you have such good granular, stable abstractions, right? And value objects are extremely good for that. They are, if you get them, and events as well, if you get them right, they become very, very stable. So even when writing new code, you're not writing low-level code. You're doing something new with mostly objects that you already have. Or same in functional programming, of course, where you would be more at the level of functions and data structures, but same idea, right? You recombine, you recompose things that are, because you kept evolving them, have become very naturally very, very composable. So it exists, and I've seen it and I've worked on them, but they are sort of rare in the wild. They exist when people have early on like hammered on this stuff and even late, right? I've also worked on legacy systems that ended up in a lot better state than they were before, because we actually and a lot of that work is very boring, right? That's part of the problem. I remember sort of finding these, like, discovering concepts that should be first class in the system, and then just sort of manually going through, you know, thousands of lines of code and replacing them manually everywhere. We are very hesitant to do this kind of work. It doesn't feel productive because it doesn't change the system itself. What I used to do actually at some point working on a government project, when we had this sort of work where, you know, we should replace this thing by this better abstraction everywhere in the code, and it's like this daunting big thing, but we gamified it. So everybody in the team was working on the same thing. We sort of split up, okay, you take this subfolder and I take this subfolder. And then we, what did we do? We had like, it was two parts. So you had to fix as many as possible. That would give you points. And then you had to find mistakes that others did, and that would give you points as well. So basically you won if you fixed a lot of code correctly and fixed a lot of other people's bugs. And then we had, I don't know, we had some reward or something. So that made it a bit more fun, but the end result was that over time we had this system with a lot of very sound abstractions. It's worth doing. It's just hard to convince people that it's worth doing, and we don't budget for it, and we don't. But if your system is supposed to exist for, you know, longer than a few weeks or months, then it's worth doing.
I feel like there's a whole talk in how to convince people that it's worth doing, but we might come back to that one. I think there are more questions here, but we might have to start to wrap up here because we are going to get evicted at some point. Yeah, look, I don't know if you can see the room very well, Mathias, but there's been a lot of nodding and smiling and really appreciative looks on people's faces. So yeah, I just want to say thank you so much for your time this morning / this evening. And
thanks for having me. All right. Thank you, everybody.